Here's the question then. Question 9. It's a long question, so I'll scroll it down. There it all is there. Okay, so let's have a go at it. I've got it summarized here. There's a part A. Find the angle between P and Q. So let's do P dot Q. I'll squeeze it in here. So it'll be 2 times 5 is 10. Minus 1 times 4 is minus 4. And then 3 times minus 8 is minus 24. 10 minus 28 is minus 18. And then the modulus of P will be the square root of 4, 1 is 5, and 9 is 14. The modulus of Q, which I'll squeeze in here, is equal to 25, 16, and 64. 64, 16 is 70, 80, 80 and 25. 64 and 16 is 80, and 25 is 105. So the angle cosine theta using the dot product will be P dot Q minus 18 over the product square root of 14 times the square root. You can put them together in the same square root times 105. So that tells us what theta is then, isn't it? Cosine is negative, so it'll be obtuse. So let's do that then. Shift cos. I'm going to drop, I'll put it over here. So shift cos, let's just drop the negative for now. 18 divided by the square root of 14 times 105 equals 61, so 62 degrees, i.e. So it's obtuse angle, so it's 180 minus 62, which is 118 degrees. Okay, that's that done then. So let's move on to part B. So here's the diagram. OA is A, so there's another A there because A dissects OD, and C bisects OB, and this is the whole of B, so this little bit here up to C will be B over 2, and this will be B over 2. Okay, so the first part show that CD is equal to this, 2A minus a half B. C to D, that's 2A, that's half B, so CD then, it's easy to see, is equal to 2A minus a half B, which is easy to see. So there's CD. Okay, we've done that then. Now here's the line. Let's just get rid of all this stuff here. I was working something out earlier to have a look. So we've got line CD is this, and line L is this. Line CD and L intersect E, show that OE is this. So here for part 2, let's have a go at it. Okay, show that OE is that. So these intersect at E. So for as far as A is concerned, the vector A components, 2 lambda A's must equal a third mu. So that tells you that mu is equal to 6 lambda. And then for the vector B component, we're going to have half 1 minus lambda must equal a third mu minus 1. Mu is 6 lambda, so you've got a half 1 minus lambda is equal to 1/3 6 lambda minus 1. So times by 6 all the way through, then 3 minus 3 lambda on the left. Times that by 6 you get 3 of these, and times this by 6 you get 2 of these, 12 lambda minus 2. So 15 lambda then here will equal 5. So lambda is equal to a third. Mu is equal to 6 lambda, so mu must be 2. So the OE then, as a vector, is equal to this many a's, 2 lambda a's, so 2/3 a, plus this many b's, so put 2 in here, and then put 2 in here. Let's have a look on the line itself, sorry. Yeah, put 2 in here for b, you get 2 minus 1 is 1/3 b. And there's the vector. Now, it says give a geometrical interpretation of OE. I got a feeling E is here. So I'm just going to work that out. So that's where the lines AB, BA and CD coincide. Well, we know CD, line CD is this. We know line AB then, or line BA. R is equal to B plus mu times A minus B, which is equal to mu A plus 1 minus mu B. So there's our line for BA. So lines BA and CD intersect when, so lines BA and CD intersect when, let's have a look. Two lambda A is equal to mu, 2 lambda equals mu, and 1 minus mu is equal to half 1 minus lambda. 1 minus mu is equal to half 1 minus lambda. Half 1 minus lambda. So 1 minus 2 lambda then here is equal to a half minus a half lambda. So move this over, we get 3 lambda over 2 is equal to a half. So lambda will equal 1/3, won't it? So when lambda is a third, what do we get? Where are we? Lambda is a third, you get 2/3 A plus lambda is a third, 2/3, 1/3 B. So R is equal to 2/3 A plus 1/3 B, which is equal to OE. That's the intersection of the lines.